So we're starting section 9.2. In 9.2, we're moving into multi-stage equations. Multi-stage equation, the stem multi just meaning many. We're moving from just doing one thing in our experiment to this and this. And so an example of that would be flip a coin and draw a card, pick a student and roll a die. We're doing now two or more things. So in our first example, a box contains 3 different colored balls, red, white, and green. And you've got a picture of it there on the right. Draw a ball from the box, record its color, replace the ball, then draw a second time, record its color. So this is a multi-stage equation a multi-stage experiment because I'm drawing a ball, I'm putting it back, and I'm drawing it again. In 9.1, I would have just drawn a ball and moved on. So the first thing it asked me to do is create a tree diagram. We mentioned this back in 9.1. Now we're going to actually start doing some examples here with tree diagrams. And so I've got 2 draws. On the first draw, the possible ball colors that I could get are white, green, or red. On the second draw, I could still get those same possibilities because I've replaced it. So if I draw a white ball, I still could draw a white, a green, or a red. On the next one, I could still draw a white, a green, a red. And then on the last one, I could still draw a white, green, or red. And so my tree diagram would be those possible outcomes. So what that means is I could draw white, then white. I could draw white, then green. I could draw white, then red, and so on. Now, we also want to go in and add these probabilities because this is going to help us later on in our examples. So on the first draw, the probability of drawing a white ball is going to be a probability of 1 out of 3 because there's 1 white ball out of the total of 3. Same thing with green. There's 1 green out of a total of 3, 1 green out of a total of 3. 1 red out of a total of 3. On the second draw, because I've replaced the ball, if I drew a white one out, I'd record the color and then I'd put it right back in. So my probabilities are not actually going to change. My probability of drawing a white ball is still going to be 1 out of 3. A green is 1 out of 3. Red is 1 out of 3. And so on for all of these. Because I've replaced the ball, the probability is not actually going to change. And so now let's look at some examples using the tree diagram to find the overall probabilities. So it says determine the probabilities of the following events: obtaining a white, then a green. So I'm looking at right here, obtaining a white and then a green ball. Well, the probability of white ball was 1 out of 3. And the probability of a green ball is 1 out of 3. And so 1 out of 3 times 1 out of 3 is going to give me a probability of 1 out of 9. Or the other way I could look at it is there's only one way to get a white then green out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 possible outcomes. Either obtaining white red or red white. Well, there's 1 white red and 1 red white out of a total of 9. So there's 2, 1 there, 1 there, which is going to give me 2 out of 9. Remember we talked about in the last video, your clue kind of when you see that word or is that we're going to add some probabilities. Number 3 says obtaining green on the second draw. Well, there's a green, there's a green, and there's a green on the second draw, and there's 3 possibilities. Let's list them. White, green, 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 or red, green. 3 of those out of a total of 9, and so that will simplify to 1/3. Probability that both balls are white. So the probability of getting white, then white, that's going to be 1 possibility out of 9, or 1 out of 3 times 1 out of 3. Probability that I would draw no green balls. And so that would be drawing white, white. That would work. I couldn't do white, green, the next one, because that would involve a green ball. But I could do white, red. I couldn't do any of these because that involves at least 1 green ball. I could do red, white, and then red, red. And so that would be 4 out of the total of 9. At least 1 white. At least 1 ball is white. Well, that would be, all of those would work because at least 1 is white. And then green, white, and red, white. So I've got 1, 2, 3, 4, 5 total out of the total of 9. Same color on both of the balls I draw. So that would be white, white, green, green, red, red. And so that would be 3 out of 9, or reduced down to 1/3. And then the probability of at most 1 white. So at most 1 white means I can't have white, white. I can have anything else. I can have 0 white. I can have 1 white ball, but I cannot have white, white. So that is everything except white, white. That would do white, green, white, red, green, white, all of these except no white, white. So that would be a total of 8 out of 9. So we've got that tree diagram up above, but in place of the tree diagram, I could have done the same thing, but in a table. We won't use the table much in this class, but it's good to mention because, one, different brains think different ways. The table may make more sense to you than the tree diagram, but also as you're teaching in the classroom, the table would be a great thing to show first because it seems a little bit more intuitive for students than the tree diagram sometimes. And so we are going to skip that second part because it's the same thing we just did. The only thing I want to mention is that this table and the tree diagram are exactly the same. The only difference is kind of the format of how they work. And so here's our next example. Toss a fair coin 3 times, record the results, and write the sample space for each of the following. So the first thing I'm going to do is I'm going to make a tree diagram just so you can see how these correspond. So I'm tossing a coin 3 times. Well, on my first toss, I'm going to draw it over here. On my first toss, I can get a heads or a tails. On the second toss, I can toss a heads or a tails. And then on the third toss, I can toss a head or a tail. And so there's a tree diagram They didn't ask me that, just sometimes it helps for students to get more practice with that. What they said is just to write the sample space. And so each of these branches is going to be a sample or an item in my sample space. So the first one would be heads, heads, heads. I tossed all 3 heads on the coin. So I tossed the coin once, it was heads. I tossed it again, it was heads. Tossed it again, it was heads. The next one would be this next branch, heads, heads, tails. And then I would keep on going, heads, tails, heads. Heads, tails, tails. And so on, tails, heads, heads, tails, heads, tails. So I got a comma. Tails, tails, heads, and tails, tails, tails. And so that's just 2 different ways to write the same things. They only asked me for the sample space, so you would just list that off if there's a test question or homework question. And then the next part says, using what we just found, determine the sample space. Now let's look at some probabilities. And so the probability of tossing 1 head and 2 tails. It doesn't particularly matter what order, just as long as there's 1 head and 2 tails. Well, that's going to be heads, tails, tails. That's going to be my first one. 1 head and 2 tails. Another one would be tail, head, tail. That would be 1 head and 2 tails. And then 1 head and 2 tails, 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 head. And so the probability of that is going to be 3 out of the total of 8 possibilities. Event B, tossing no heads. Well, the only one that satisfies that would be tails, tails, tails. And so that is going to be 1 out of 8. And then the last, event C, tossing a tail on the last toss. And so those possibles would be head, head, tails, head, tails, 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 head, tails, and then tails, tails, tails. There's going to be 4 out of 8 or 1/2.